Hello, welcome to Introduction to Composites course. Today is the 4th day of the ongoing week. Yesterday we had just started discussing polyester resins and how they are produced, and we will continue this discussion on polyesters today as well. So, one thing I wanted to mention is that we had explained earlier that to produce polyester you require a resin, you require a monomer, and typically it is styrene. Okay. And these two, when you mix and you want to initiate the reaction of cross-linking between different chains, you add a trigger or a curing agent, and so you add a trigger or a curing agent. And once this thing is over, then that is when you get your final thermoset solid matrix material. This is how you get the process. Now, based on what type of resin you pick and what type of monomer. So, here I have said that you can use this monomer as a styrene, but based on which resin you pick and which monomer you pick, you can change the material properties of the final product, which is the thermoset solid. Okay. So, typically you use this resin as diethylene glycol. So, it all again depends on what constituents you are using. So, this is the raw material, but you can use other alternatives, could be other glycols or acids. Okay. Similarly, instead of styrene, this is a monomer, you can use some other materials and you can get different properties of the final product. So, this is the overview. Now, finally, in context of polyester resin, let us look at some of its properties. So, properties, and here we have value. Okay. So, the first one is specific gravity, and this value can move anywhere from 1.1 to 1.4. Next value is modulus, tensile modulus, and this is in MPa. This is anywhere between 2000 to 4400. Tensile strength, this is again MPa. So, the strength is, it can depend 33 to 104. Coefficient of thermal expansion. So, what is coefficient of thermal expansion? Units are into 10 to the power of -6 per degree centigrade. So, this is 55 to 100, and the last one is water absorption percent, and water absorption over 24 hours. Okay. So, you put something for 24 hours in water and see how much water is absorbed. So, it will absorb anywhere between 0.15% to 0.65%. Now, compare these with steel. Steel is the most common engineering material used in the world. What is the density? Density is about 7.8 for steel. Okay. Tensile modulus, it will be 200,000. So, roughly the tensile modulus of this matrix material is 100 times less than that of steel. Let us look at the strength. Strength typically of steel would be maybe anywhere from 300 MPa to, if you really go to great type of steels, super strong steels, it could be 300 to 1000. So, the point is that you should have a perspective. Okay. This is steel, this is where our plastic is, this is where our fiber is. Coefficient of thermal expansion. Coefficient of thermal expansion is about 12, depends on the steel. Okay. And of course, water absorption is 0. So, this gives you an overview of thermo set resin known as polyester. So, roughly speaking, 100 times weaker than steel, right, 10 times weaker than, 100 times less stiff than steel, 10 times weaker than, 10 to maybe 30 times weaker than steel, and it expands much more, 4-5 times more than steel. So, this is all about polyester resin. Next, let us look at epoxies. So, this is also a thermoset resin. This is also a thermoset resin. So, how do you get it in market? So, like polyester, if you want to go to market, what do? You buy some resin, you buy a monomer, you mix them in some proportion and you add some trigger, or in some cases you may get a mixture of both these together, and then you add trigger to it and then it just starts curing. Similarly, if you want to go to, if you go to market, you will get it in two parts. Okay. So, either you may get as a single part some fluid, or you may get as a two-part epoxy. So, you get it in fluid form. Okay. And then you have again a trigger. You again have a trigger. This is also called as a hardener or curing agent. Okay, or activator. So, one example of this trigger is diethylene triamine. Okay. So, you take this main material, mix it with trigger, and you get the curing going. Now, as I said, in some cases these epoxies come as already in a pre-mixed state. Okay. So, you may have pre-mixed or separate. So, this is in pre-mixed, it is one part, and if they are in separate, you have two parts. In premix, you do not have to worry about mixing in the right proportion, it is already mixed. So, all you have to do is you have to just apply heat, you have to save it or store it at low temperatures so that the reaction does not proceed. In separate, you do not have to worry about solidification. So, you can store them at room temperature, but then you have to mix them in right proportion and then get the reaction going. Like polyesters, epoxies also, when they cure, they generate heat. So, it is a exothermic reaction. It is an exothermic reaction. The second thing is, like polyesters, they also undergo shrinkage. During curing. And as in the case of polyesters, I forgot to mention this earlier when we were discussing polyesters, the rate of reaction, it goes, so it increases exponentially with temperature. So, a lot of times the way what people do is, if they want to generate they increase the temperature, they make and this curing happens at an elevated temperature, and it also generates its own heat. So, they have to make sure that they maintain the temperature at a certain point, and that is how the thing is cured. Okay. But if you raise the temperature very high, then the curing will be fast, but the quality of the curing may not be great. Okay. So, there are some standard guides as to what kind of temperatures should be maintained to make sure that curing is of a good quality. So, this is about epoxies. Now, look at the properties of polyester. So, this is polyester, and what we will do is we will add the values of epoxies also here, so that you can have a comparison. Okay. So, the first thing we discussed was density. So, density does not change much between polyesters and epoxies, 1.2, 1.3. Polyester is in general slightly lighter, 10% lighter. Tensile modulus, it is a little stiffer, not little, appreciably stiffer, 2500 to 4500, 20% stiffer. Strength is where you get more benefits. So, it is a much stronger material, 50 to 150. CT not a whole lot different, 45 to 70, and the other significant advantage you get is that epoxies absorb much less moisture. So, they absorb something like 0.05% to 0.15. So, if you have a situation where there is a lot of moisture and you do not want to have these kind of moisture absorption related problems, then it is really good to have epoxies. The other thing is that the glass transition temperature of epoxies is significantly higher compared to those of polyesters. So, they can take a lot of temperature relative to polyesters. So, in a lot of high end applications where we need strength even at some elevated temperatures, we do not go for polyesters, but rather we opt for epoxies as the matrix material. But cost wise, epoxies are much more expensive compared to polyesters. The third category is vinyl esters. Vinyl esters. Okay. So, some broad comments about it. They are similar to polyesters in terms of their material properties, behavior. Viscosity is low. So, what does that mean? That if I want to impregnate this matrix in a fibrous system, all this matrix has to flow between all the fibers. If its viscosity is very high, it will not flow easily, but because in vinyl esters viscosity is less, so it flows in easily. So, actually this should be viscosity, misspelled. so viscosity, and they also cure faster. Better mechanical properties, better mechanical properties. One thing we had mentioned or was that polyesters are susceptible to ultraviolet radiation. So, less sensitive to UV, better chemical performance, and they are, where do we use them? We can use them for chemical vessels, tanks, pipes, etc. Okay. Very quickly, their properties. So, the density or specific gravity is anywhere between 1.1 to 1.3. Tensile modulus in MPa, that can actually range from 3003 GPa to 3.7 GPa. The strength, tensile strength. So, tensile strength is actually measurably higher. So, this is 33 to 104. So, these guys vinyl esters are somewhere in between. So, 70 to 81, and CTE is again not a big difference, 50 to 55. So, broadly speaking, you have polyesters at the low end, epoxies at somewhat higher end, and vinyl esters are somewhere in between. That is where they are. Let us look at one more material system. So, these are polyimides. Polyimides. The good thing about them is that you can use them at higher temperatures. So, use temperature can be as high as 300 degrees centigrade. They are very inert materials, very less reactive materials. So, resistive to solvents, gases, etc. Very strong and stiff. Okay. One example of polyimide is known as BMI. It is a short form, and it is bismalimides. So, this is bismalimide. But these guys are also brittle. So, we have to think about it. Quickly, some of their properties: specific gravity. So, this is a little high, 1.4 to 1.5. Modulus. So, it starts from 3500 and it goes to 5000. Compare it with those of epoxies, right. So, it starts somewhere from the midpoint of epoxy and exceeds that modulus. The strength is 120. So, much higher than those of epoxies and this thing. It absorbs a lot of moisture, CT is high, and water absorption is also high, 0.3%. So, these are some of the important thermoset resins, and because these guys polyamides are resistive to solvents and gases, and they can be used up to as high as 300 degrees centigrade. They are used quite frequently in chemical plants, especially where temperatures are, operating temperatures are less than 300 degrees centigrade, because then they are very resistive and stable materials. So, this concludes our discussion on thermosets, and starting tomorrow we will discuss other matrix materials, metal based matrix materials, ceramic based matrix materials, and also we will also discuss some of the thermoplastics which are popular in the world. So, with that we conclude our discussion, and I look forward to seeing all of you tomorrow. Thank you.